Just think about it for a moment. Right now, at this very second, your mind contains countless memories. Some were formed just 30 seconds ago, while others go back 30 years. Somehow, they all coexist. But here's something strange. Your brain doesn't store memories the way a computer stores files on a hard drive. There isn't a folder labeled your 8th birthday where that memory is kept. So, where do all those memories actually go? And why can you vividly remember your childhood best friend's smile, yet walk into a room and instantly forget why you went there? Today, we're going to explore how memory really works, what science says about it, and the fascinating research that has helped us understand it. Before we dive in, let's clear up one important misconception. Psychologists say memory isn't just one single thing. Instead, it's a process made up of 3 different stages that your brain has to complete. The first stage is encoding, which means taking new information into your brain. The second is storage, where that information is maintained over time. The third is retrieval, which is the process of bringing that stored information back when you need it. Think of a library. When a librarian catalogs a new book and places it on the correct shelf, that's encoding. The book remaining safely on the shelf is storage. And when someone walks into the library and successfully finds that book again, that's retrieval. If anything goes wrong during any of these 3 stages, memory appears to fail. That's what we experience as forgetting. In 1968, psychologists Richard Atkinson and Atkinson-Shiffrin proposed the multi-store model of memory, a theory that remains highly influential today. According to this model, information passes through 3 stages before becoming a lasting memory. The first is sensory memory. Every second, your eyes and ears receive an enormous amount of information from the world around you. Most of it disappears almost instantly. Visual information lasts only about half a second, while sounds remain for roughly 3 seconds. That's why, if someone speaks to you while you're distracted, you can often replay the last few words in your mind even though you weren't consciously paying attention. If you focus on that information, it enters short-term memory, also called working memory. This stage has limited capacity and lasts only around 20 to 30 seconds unless you actively rehearse it. On average, people can hold about 7 pieces of information at once. That's one reason phone numbers are grouped into smaller chunks. Our brains remember organized information much better than long strings of unrelated numbers. If information is repeated or, even better, connected with meaning, it can move into long-term memory. As far as scientists know, long-term memory has no known limit in either capacity or duration. Modern neuroscience supports these ideas. Brain imaging studies have shown that when people encode new information, the left prefrontal cortex becomes more active. When they retrieve old memories, greater activity appears in the right prefrontal cortex. In other words, your brain uses different neural circuits when storing memories and when recalling them. Another important structure is the hippocampus, a small seahorse-shaped region deep inside the brain. It plays a vital role in memory consolidation, the process of transferring information from short-term memory into long-term storage. Much of this consolidation even happens while we sleep, which is one reason why good sleep is essential for learning. One of the most famous cases in psychology is Patient H.M. in the 1950s. Part of his hippocampus was surgically removed to treat severe epilepsy. Although the operation reduced his seizures, it also produced a remarkable discovery. H.M. could clearly remember events from before the surgery, but afterward, he could no longer create new long-term memories. Every meeting with the same doctor felt like the first time. His case demonstrated that the hippocampus isn't where old memories are permanently stored. Instead, it acts as a gateway that helps new experiences become lasting memories. Here's another surprising fact. Most forgetting is a failure of retrieval. Then what is retrieval failure is? Have you ever had a word that's right on the tip of your tongue? It's like you know a word or a topic, but you simply can't say it. Psychologists call this the tip-of-the-tongue phenomenon. It suggests the memory is still there. The retrieval pathway is just temporarily blocked. That's also why retrieval cues are so powerful. A familiar smell, a favorite song, or a particular place can instantly bring back memories. Our brain recognizes the tag and uses it as a shortcut back into the original memory. Even if we couldn't recall the memory on our own, the matching cue can unlock the path to it. This is formally called the encoding specificity principle in psychology. Memory isn't a filing cabinet where information simply sits untouched. It's a living, dynamic process that your brain is constantly building, strengthening, and reconstructing. Every time you remember something, your brain actively recreates that memory. So the next time you suddenly remember a childhood moment because of a familiar smell, or forget why you walked into a room, you'll know exactly what's happening behind the scenes inside your brain. If you enjoyed this exploration into the science of memory, subscribe to Psyched Insights for more educational psychology videos every week. And before you go, let us know in the comments, what's one memory that's still incredibly vivid to you, and what do you think triggers it? Thanks for watching, and I'll see you in the next video.